Welcome to Three Devs and a Maybe, the podcast series for beginner web developers and general web enthusiasts. Now, introducing your show hosts, Michael Budd, Fraser Hart, Lewis Keynes, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we are very lucky to be joined by, and I should have asked this off air, Dan Abramov?
Yeah.
Abramov.
Hi.
Got it perfectly. Thank you very How are things going, Dan?
Pretty well. I'm actually going to England soon because I got a job at Facebook.
I've been looking at your Twitter yesterday and I noticed the visa and I was thinking, oh, hang on, London to England. I thought this is brilliant.
Yeah, I was actually, I don't know, it's maybe silly, but I was pretty nervous about this whole visa business because, you invest in something like some process that spans over multiple months, and at the end, you might not get the visa. So I'm really
That is
happy
it. There's so many moving parts I can imagine that you've got to work with, yeah. And it's all come together, which is great. Well, congratulations on that. So you're going to be moving to London then, working at Facebook?
Yeah.
Awesome. That's great. Well, I'll hopefully see you at some meetups. Like I said, over Twitter, it'd be great to, catch up. It'd be great.
Yeah.
I mean, for the audience, so Dan is of, Redux or Flux kind of fame, as well as React Hot Loader. These are technologies I've been banging on about in previous episodes. I've been working on in my day job. We've started using React and Flux and these technologies. And I suppose for me, kind of bringing you on and it's kind of to have like an expert in the field of all this. Because, how long have you been using Flux and React and things like that?
I think I started using React maybe 2 years ago. I would say so. 2 years ago it was.
Brilliant. And I suppose rewinding all the way back to the beginning, like how did you actually get started in programming? What was your kind of foray into it?
You mean like how I started programming at all?
That's it, yeah. Straight from the beginning.
I think I was about 12 years old, and I wasn't like my friends. They all had computers by the time they were 9, but my family actually didn't want me to buy a computer because they were afraid I'd spend all the time playing games. And I was playing a lot of games back then on Sony PlayStation, so their fears were justified.
they had evidence that could have...
Yeah, but when I got the computer, I had problems with keyboard. I didn't really like to play games with keyboard. I was used to Sony joystick, so I didn't play games. And I remember I had an assignment in school. We had lessons about Microsoft Office, and I had some assignment related to PowerPoint. I was supposed to make a presentation about something. And I remember PowerPoint being my favorite app of all because I could tell things to animate and schedule animations. Yes. Yeah, I love that. Like when you click on this item, it slides to the left and then something happens. So this kind of stuff, I was very interested in that. And one day I discovered a menu item called service macros. And I didn't really understand what's going on, but there was a record button and the play button, and when I could record some actions on the slide, and then I press play, and they repeat themselves. And I was like, what's that? And I press edit, and I see a bunch of English words and numbers, and if I change the numbers, then the things fly in different directions. So I was really mesmerized by this, and I saw the title Visual Basic for Applications on the window, so I went to some bookshop and I bought a book on the Visual Basic for Applications. And then every weekend I would ask my grandma to go with me to a bookshop, and I would buy the next book.
That's awesome.
So that's how I started.
That's great. And then through that, did you then do go through the like learning ranks of it, educational ranks, going like to university and things like that, or did you just go off into your own?
I tried to do that. I entered the university in St. Petersburg, same place where I lived, and yeah, I I didn't really like it at first. I was hoping that it would be more about programming in the future, but they had the same curriculum for all students. So the first 2 years were the same for pretty much everyone, so there wasn't much programming there. And by the end of the first year, I was really not much interested in visiting it because there was a lot of math, a lot of physics, and barely any programming. And so at the second year, I just stopped going there.
I don't blame you. Yeah, you wanted to be going because did you have your heart set then on programming as like a way of life?
I got my first job at the end of the first year when I turned 18. So after I got a job, I was like, hey, that's the real thing. And what I'm doing at the university, that's just, I don't know.
That's not for you. Not for you.
Yeah.
And then so from that, what technologies were you using then, in your beginning of your career?
When I started, it was all Visual Basic because that's just what I started from, and it was kind of hard at first because everybody kept saying like, "Hey, that's not a real language, right? Go and learn C."
Go and learn this.
Yeah, and I actually bought a book on C++ by Charles Sharp, and that was a really horrible decision because it's not really a book for learning it. It
scares the crap out of you.
Yeah, exactly. So that didn't help at all. And I think later Visual Basic was discontinued. They had this Visual Basic.NET transition, which is a whole different language. And by the time .NET shipped, I kind of started looking at C#, and eventually I got comfortable with it. So I spent the next several years working with C#. So I was working on desktop apps first, and then I got a job. I was working on some outsourcing projects, like for financial companies, boring enterprise stuff. And later I got into a startup where I used C# to make an iPad app using Xamarin.
Oh, wow, that's cool.
Yeah, so it's native, but I was writing it in C#. And at the time, it was a hybrid app, so I also had to learn some JavaScript. And eventually we discontinued the iPad app, and we were working on the web version. So I really had to learn JavaScript.
that was where, yeah, completely. And the back end of that, was that ASP.NET that you were using?
No, I didn't. We were using Python because that's what the backend guy knew well. So I kind of had to learn bits of Python, although I still don't understand a lot there.
Like significant white space. That's all that matters.
Yeah. But I get comfortable with JavaScript eventually.
That's it. So yeah, so you got into the JavaScript section. Did you there was no going back now? You kind of fell in love with it?
Yeah, it's a love-hate relationship, I guess. And right now I think I'm in the love phase because after you kind of get most of the quirks, I can say that I really know it. Like, this website, you don't know JavaScript something. Like, yep. It's a book. And I tried to, I was like, yeah, I know it. And I tried to go through some exercises and I realized, no, I don't really know it. But if you learn to avoid these edge cases where you just need to read the spec to know the behavior, it's kind of a nice language, in a way.
Did you find that
bad?
Did you find that Douglas Crockford's book helped you at all? Did you read the Good Parts book that kind of helped solidify it?
I haven't read it. I just went along with what people were using, like JSHint and JSLint and later ESLint. So I kind of know that part of JavaScript, and I try not to think about conversions, all that implicit stuff.
No, absolutely. And then so from that then, so you kind of transitioned from the C# one. And did you actually enjoy C# going back for that? Like, were you a fan of the C? Yeah, you enjoyed it?
I enjoyed a lot of it. I did not enjoy Java at all when I looked at it, but I really enjoyed how the C# and the .NET team, how they were taking some functional concepts, like link. It's
beautiful, isn't it? I mean, that really is great.
Yeah, and on the other hand, they were never like architectural astronauts. They always thought about the common guy or girl, like if we take these concepts, how do we make them accessible? How do we make
the pragmatic approach on it? Like, how can we use this in the real world?
Like, this part doesn't make sense. Nobody's going to understand it, so we're not doing it.
No,
that's cool.
Yeah, it is very cool, and I find that language C# really does move a lot quicker than its competitor, which Java. Yeah. And did you enjoy like Visual Studio? Because I think that's one thing with C# that I loved is the tooling around it, because they own the whole ecosystem. They can make such good tooling.
Yeah, I think there were some parts of it that I didn't understand at all, like when it got all drag and droppy with all these data objects. You drag and drop.
Those abstractions were very, they were annoying. Sometimes it would be trying to make it too simple, and as you say, drag and drop, where really you just wanted some code behind it.
I was refactoring a complex application once when I was at my outsourcing job. So we got some legacy app that was written by some folks who didn't really know the language much, and they drag and drop everything. Oh, no. It was a horrible mess.
Oh dear, yeah. The code that's generated by that is not, and it just makes it a lot harder.
Yeah, but I was saying that, but it's great to have tooling. I think after a while, I stopped reading books on programming because they just couldn't catch up to the tools.
Yep.
So the way I explored the APIs was from the Visual Studio itself. So like when they ship the link, I would press, I declare an enumerable variable, and I press dot, and I see all the methods that I can call, and I can see the documentation for every method. And
then you can experiment with it, and that's the great thing. And you're able to like really hands-on experience of using it, as opposed to this kind of tutorial way in books and stuff, and being able to just do it there and then.
Yeah, exactly. And I kind of miss it. I don't use IDEs anymore. I just use Sublime Text. And it was painful at first, but then I got used to it, and now I'm feeling like I don't need an IDE. But I think I'm kidding myself, because it would be really beneficial if I could use strong type.
I think that's it, isn't it? Yeah, it's that. And a registered version of Sublime, we should say. If people don't, we do. You do have a registered version. That was.
Yeah, I do have it.
That's for the people. Put in the show notes the video. The worst timing, wasn't it? Had to be the worst timing. You're like, oh great. No, I do have one. It's not a joke here. Oh dear. Yeah. But so with the JavaScript stuff then, so was it vanilla JavaScript at first? That you kind of just the hodgepodge of jQuery, or was it really a structured backbone kind of application to start off with that you kind of work with?
I think my first attempt to do something, I didn't actually use JavaScript at first. I used CoffeeScript.
Oh wow! Okay, yeah.
Yeah, it was popular, and I kind of thought that like JavaScript is horrible. I'm going to use something better. So,
and did you go? Did you find how quick did you realize I want to go back to just vanilla JavaScript, or was were you happy
after not looking at the code for 6 months and getting back to it?
Yeah,
I think. And that was the time when I was already. I think we had a new team member at the time, and he was more experienced in JavaScript than I was. And he was like, hey, you're doing it all wrong. You're supposed to use grunt and linters and all that stuff, all the tooling to catch your mistakes. Like, you don't have to write JavaScript like you did in 1999 anymore.
You have all this tooling around it that you can use.
Yeah, and after that I realized that, I should just use JavaScript.
And was that JavaScript ES5, and then you were able to then do ES6 and stuff like that, or were you?
Yeah. We started with ES5. I think the first time we built something complex with it, it was my first JavaScript app, and it was using Backbone because I kind of knew Backbone. It wasn't hard to learn. So we used it for models and for views, but it got really complicated because we had a lot of asynchronous stuff. We had a lot of asynchronous UI code, like when you wait for some popover to close, and then you need to transition to another route, which needs to load some models to display. So it's gotten really messy. There were a lot of edge cases, a lot of bugs that are hard to reproduce. So I think that was the time when this same coworker suggested that we use React. And I looked at React and I didn't understand a thing. Like the JSX,
it blows your mind when you first look at it, doesn't it? It does feel completely foreign.
Yeah, it was bonkers. I thought, no way we're using it. But I think in a few months, I had this particular task. Like we didn't set up for any kind of rewrite. The coworker suggested we use Angular, but I wasn't comfortable with it because I didn't know it. So I just kept on using Backbone. And then I had this task where I have several widgets that are in different parts of the page, and they're supposed to, when I press on one widget, it's supposed to update the state of another one, and they all have multiple states. So it's
and you were crying thinking that you were going to have to do this all in Backbone. You thought, oh no.
Yeah, we had very rudimentary system for data binding, like really stupid system. We had data attributes and like data field equals some field, and if it changes, our base Backbone view was supposed to re-render that part of the template and replace the DOM node. But it was really dumb and it didn't work at scale. So when I had this complicated task, I was looking at React again, and I tried to prototype it in React, and it worked the first evening. And this was the point where I realized, yeah, I want to make it, I want to write code like this. I want to write if something, return some div, or return some other div, and let React figure out how to
do the hard stuff. Absolutely. Yes. And so this was on top of Backbone then? You were using Backbone as your model layer and then using React just for the view?
Yeah.
That was, yeah. And you felt, and did you start then bringing that more into the company and eventually take over the world with React?
Yeah, exactly. We started using React in the dynamic UI and in any new UI, but we didn't change the old code unless we had to. But eventually, it started propagate up the tree, so to say. So if you got 3 components that are React components, it's pretty simple to turn their parent into React component. So React kind of propagated up our component tree, and the only missing piece was the router, because there was a React router component by ngpop, but we couldn't get it to work with our URL structure. And so we just waited for something to pop up, and then React router came out. And I took a weekend and ported it to React Router. So the only missing piece after that was switching from Backbone, because actually Backbone got really painful at the time, even for models. And we were waiting for something to come up. And then we saw the presentation about Flux, and I was like, yeah, that's
it. I'm sold.
Yeah,
this is it. So going back a bit, actually, so React. So what is React for a complete beginner? What would you say React is?
I would say it's, if a beginner is aware of other JavaScript libraries, sure, he might be familiar with Angular or Ember that have these base class libraries. Like they have all sorts of their own syntax for templates, and they have all sorts of components, like built-in components. Directives in Angular, if I'm not mistaken, and all these things have their own APIs. So that's not the case with React. With React, you only have like 10 methods that you need to remember. It's a very tiny API surface, so you don't need to Google it all the time. And the idea of React is that instead of writing your DOM changes by hand, like when some model changes, I'm going to update this part of the DOM. Instead, you write your code as functions, like how does the DOM look? How is it supposed to look given the current application state? So you can write code like if some condition, then I'm going to return a div with a p inside and some link. Or if if this condition is false, I'm going to return some other DOM element. And so you describe every part of your application as a reusable component that can contain other components, and every component is just a description of how the DOM should look like. And React figures out how to actually transition from the previous state of the DOM to the next state with minimal DOM operations.
That's its secret sauce, isn't it, really? That is the secret sauce of being able... It reduces your overhead, mental, cognitive overhead of thinking that way.
Yeah, because the biggest problem, like if you have many states in your app, like you have a button that can be pressed, unpressed, and in some pending state where you can't press it, and so on. You have all these states. And if you add a new state, for example, the designer asks you to, I don't know, highlight it differently for registered users, you need to figure out how to transition to and from the state, from every possible state you already have. So if your code is jQuery soup, you need to account for the new state in every possible transition. But with React, you don't need to write the code for these transitions. You only need to write the code for the state. So it's like instead of n times where you need to change the code, you just need to change the code once. So that's the big benefit.
Really big sell, absolutely. Yeah. And I mean, it's very funny because it is a very pragmatic approach to it, because you know, obviously it's the view layer, but then you meld data with that view. I mean, you can look at it as if you're using props on their own, it is very pure. You know, the props come in, the state, you know, the view comes out, but you can also use state within there as well. Yeah, and I'm just wondering, because everyone, I mean, when I first looked at it, the one thing for me was, oh dear, you know, you're mixing the view layer with your data concerns and, you know, the domain logic, but it kind of goes into this way of just thinking of components instead. You know, like this is a component that I can put on a page, as opposed to, you know, strict defined layers. I'm just wondering, like, how does that work for you? Did you like the way of thinking of components and being able to?
Yeah, I think it's important to think about this as you think about functions, meaning that you don't have to write spaghetti code, right? And a lot of people say that React forces you to mix your presentation and the logic, but I think it's the same as saying as functions force you to mix your presentation and logic. Of course, you can put presentation and logic in a function, but you can also separate them.
Yeah.
And it's the same for components. You don't have to mix this. You can have components that are only concerned with presentation, that are only concerned with how this piece of data turns into a piece of UI, into DOM, or if you're writing for React Native, into iOS views. But you can also have the container components, or this is not a React term, it's just arbitrary distinction, but you can have these smart and dump components, or container components, people like to call them different ways, which are just components that don't have any DOM associated with them, and that only provide some kind of logic, or not even logic, probably rendering logic for other components. And it's important to note that in React, one components don't have to return DOM. They can return other components. So you don't have to wrap components into divs or something to reuse them. You can have one component that returns another component, but processes its props to prepare them for rendering or something. And that's a really powerful pattern.
Absolutely. And I mean, one thing I have found is the functional programming kind of, it's slowly leaking into, you know, React has kind of allowed for this, you know, way of thinking, and, you know, people take it, you do have the ability to use state, but you also lean on the side of using props and having this idea of, you know, I pass this in, I'll get this output, and it'll be the same each time. And I suppose, like, for you, have you done any functional programming before you came to React?
I think I learned it a little bit when I was just still playing with C#. I got distracted by a functional language called Nemurl, if I'm not mistaken. That's how I pronounce it. It was a very esoteric language for the .NET platform that had macros and a lot of functional programming utilities. And that's kind of how I got interested in it. And I didn't really write programs in any pure functional programming language. Like, I don't know SML or Haskell, but I have an idea about them, and I try to learn new things about functional programming time after time.
No, I think it's great because it brings, and again, it's that pragmatic approach of it's working well in this area. It's using these concepts, similar to how we were talking about C#, bringing it to the mainstream. Yeah. It brings these concepts to the mainstream that work and can be shown to work.
Yeah, I really like Sebastian Magbe's attitude here because he's one of the core guys in React team. He's a bit of a philosopher, and I like his attitude that he's not forcing functional programming onto anyone, and he says that it's important to educate first. So you don't really want to be all highbrow and say, hey, this is our pure functional land, and you're a beginner, you don't get it, so...
you have to be on this level before you can even touch this.
Yes, and Sebastian is like, no, if you need an escape hatch, it's our problem. Like, we need to give you an escape hatch, and we need to educate you. So this is our responsibility as framework authors. So, yeah, I think that's really noble. I like it.
It's a really great way because, again, it allows people to make mistakes or to feel comfortable, while using the things that they already know, the imperative paradigm, and then be able to go into a different, realm and slowly build up. And I think that's a much better way than this kind of strict, you're on that level or you're on that level and there's no in between.
Yes, and it's also, like you said, it's important to let people make mistakes because... for example, I'm really opposed to mixins. They're part of React traditionally, but React is slowly not really deprecating them, but it kind of tries to not encourage people
with
to use them.
With ES6, it seems to kind of support it. Kind of has gone away.
Yeah, it's gone away, and they're you don't have to use ES6 classes, right? But they're kind of trying to. I think they're hoping that by the time there is a mixin solution for ES7, people learn not to use mixins.
That's it. Yeah. The time frame.
Problems.
Yeah, by the time frame, they won't skip. Thinking, the ES6 support, and they'll be like, I can do it again.
Yeah, exactly.
And so you've got React, and you've got this, idea, that it's a, this idea that you pass in state, and then it returns you a layer or a transform, a state in time that then at this time, in the state of, using it on the in the browser, the DOM will change. And I know there's been a lot of push, to kind of get away from the fact that React is just for the DOM as well. Mm-hmm. Yeah, and I think that's happening in version 0.14 was a massive shift there where they've broken out the idea that it's just for the DOM. I'm just wondering, because you've got now it also for iOS, React Native. I'm just wondering, where have you seen it being used in any other areas that are strange, kind of ways that it's been used? Yeah.
So what React 14 does is that it separates the idea of renderer. They always wrote React the way that you could replace the renderer, but it was all inside this one library, and people said it's not modular.
It is stuck. It's all binding together.
But what Sebastian often says, and every time I talk, I'm quoting Sebastian all the time. But what he says is that no abstraction is better than the wrong abstraction. So what they really wanted is that don't split the packages until you're sure what exactly you want to split and what API you want to have. So now that they have React Native, they figured out the parts that need to be replaceable. And with React 14, they separated the DOM part from the base React library. And they are working, it's still work in progress. They are working on bringing React Native to just be a renderer for the main React library. Because right now, React Native, it has its own fork of React inside, with some changed files, but they are working on making it a renderer. And you asked about exotic renderers. I've seen some really interesting experiments. There is a project called React Blessed, which is a React interface to Blast console library for Node.js.
Oh, wow.
And it lets you render, it lets you write Node.js console applications, no browser, but with React. So it's the same conceptual model, but it works against the console. And another example, I think one of the first examples was called React Art. And I think actually Sebastian wrote it, if I'm not mistaken. And it's an interface to art library, which can render to Canvas and WebGL and something else. And I saw yet another example with WebGL. I think if you renders for WebGL, and there was also something else. I mean, a lot of people are
a lot of work going on in this space, absolutely. And I think it's great that this idea, and I think that's the idea of the great, the abstraction, working out what's the point in breaking it up until we know exactly what we want to break up. I think that is a really pragmatic and a great way of thinking, because as you say, now we've got that problem. Oh, right, okay, we know that we want now to break it up in this way. Beforehand, they didn't have that idea, and why not? Go for the problem. It's like having that, the idea of the Twitter, fail whale where, oh, it's great that you've now got this problem, like, okay, now people are using it and they want to use it. We can now break it up in this way.
Yeah.
And when you were talking about like the backbone, so you had React as the view layer, and then you slowly, kind of looked into, you wanted to change how, your kind of the infrastructure around, the data and that, and then you moved into Flux. And you spoke about Flux, and I'm just wondering, so for the complete beginner, again, similar to how we spoke about React, what is Flux then? Because I think people get confused by these terms. You've got Flux and React,
so it's a way of applying changes to your data. I think so. It feels the similar role to MVC. So if you use MVC, you're not using Flux. If you use Flux, you're probably not going to use MVC. So these two are conflicting. And in MVC, if you come from traditional background where you have these models and views and controllers, or just models and views, you're going to have a problem, I think, in a really complex application. You're going to have a problem with models having too much responsibilities, and with models doing things that are hard to track. Like, for example, if you have an application where you have a follow button for a user, so you can follow another user, but when you follow another user, it's important that both your followed counter increments and the user's followed counter increments, and that the Boolean fields are set correctly, that the request is sent to the server, and then if the request fails, it's important that you roll back both of these increments, roll back both of these Boolean fields. So that's a lot of interaction.
That's a lot of interactions, a lot of moving parts.
Yeah, and imagine if you can press this button several times and several concurrent requests come out, and some of them fail. Like, it's a mess.
And you can't replicate that, can you? I mean, that is, again, it's this spaghetti code that you can't, easily work through.
Yeah, and most of the time, the complexity is due to async nature, and it's due to models owning their own state and being able to change other models. So usually I'd write this code as a user object or user class having a follow method with another user, and this follow method is just going to set fields on them, wait for the promise, and then reset these fields. And it's a mess because it's hard to say who's in control, like which user object changed which user object, and why did they trigger a re-render, and who's subscribed to them. So it's a lot of cascading updates. When one model changes another model, which changes a view that is subscribed to some other model. So it's a mess. It's very hard to track. It's very hard to reproduce bugs, because if you have a bug report that your program is in some weird state, and even if you look at it, you can't say how exactly did it get to this.
That's it. How can I replicate this bug of, getting into it so I can actually work out what the problem is?
Yeah, because it may have been due to some race condition with some models setting fields on each other, and you can't really get it into the same state again. So that's a problem, and it's a problem only in complex applications. So when people look at Flux examples and they see to-do MVC or counters or, I don't know, something simple, and they're like, why do I have to write so much boilerplate code to get this to work? Like, isn't it 10 lines in jQuery and Backbone? But the problem is that those 10 lines don't scale. They don't scale to complexity. So what Flux attempts to solve is it attempts to solve this complexity. And the way it does that is that I think the most important principle of Flux is that the state is read-only. The models are read-only. There are no set methods on them. And that's the big idea of Flux. So the things are called in a different way. You have stores instead of models. But what's important is that the views or network requests or any other code, no code can change the data. So how does the application actually change? Because, of course, we need to change the data once in a while. So in Flux, you have to describe the changes. So if you want something to happen, like you want the user to follow another user, you want to update that field, what you do is it's called dispatching an action, but that really means that there is one event bus, a global event bus. It's called the dispatcher. So you pass an object to that event bus, and that object describes what happened. So how do you describe that a user followed another user? You can do that by a JavaScript object that includes the ID of the user who was followed, the ID of the user who followed that user, and what is the action type? Like, what happened? User followed another user. So you have this type, constant type string inside that says type is user followed another user, and that is just a JavaScript string. It's a constant. So anything that happens in the application, any mutation I want to make to your state, you have to describe as an object, and we have to dispatch it to this global event bus called the dispatcher. And the models called the stores in Flux terminology, they listen to this dispatcher, and they are the only ones who can change their internal state. So they update themselves by receiving news about what happened in the application through actions. And now the views, they update themselves when the store state changes. So Flux kind of, it straightens your, it forces your data mutation to follow a cycle. Like, you have to express everything as a plain object. The stores have to react to these objects, and the views have to react to the current state of the store. And the reason it wasn't popular before React is because we didn't have a view framework that can update itself in response to arbitrary changes. So in classical MVC like Backbone, you usually emit the event like change name or change email, change something. You have to know what exactly changed to update the view layer, like to have jQuery, HTML, something. But in React doesn't really care what changed. It can efficiently re-render your view no matter what changed. So this is why Flux works. The actions are fired, the stores update, and the view doesn't care what exactly changed. It just re-renders with a fresh state from the stores. So that's Flux in a nutshell.
No, that's brilliant. Thank you. That really is a great, description of it. And, I think, as you say, like the way that React kind of complements Flux so well, I don't think, because without React, would Flux be at all as popular or kind of be an option that you could use? Because, you're kind of having to get away from the fact of knowing what's changed.
Yeah, I don't think so, because it would have been much more complicated. So Flux is complicated enough, but
adding that on top of it
complexity. Yeah, but adding granular changes would be a mess.
And did you find this that you when you were working with your Backbone, that this was the problem that you had, and then Flux bringing Flux in helped resolve that problem?
Yeah, exactly. I think a lot of people are confused about Flux because they didn't really have these problems in their apps. But we struggled with this every single day because our app was pretty complex. It was a single page application. And the state of different models would get out of sync all the time. It was really hard to have this backbone collection of models and another backbone collection of models. They influence each other. And we have these nested API responses from the API server where it has duplicate objects. And if the user edits some object, then it's going to appear updated only in one place. But other objects that are, from the point of view of the application, they are the same, but they are different objects because they were parsed at different times in Backbone. So they don't reflect their current state. They get out of sync. And it was such a pain. Like
I can imagine.
Yeah, all parts of our app would get out of sync all the time. And this was actually how Facebook came to Flux too, because they had this chat part of Facebook, and it was split into several different parts of the UI, like the counter in the top bar that says how many unread messages you got, and the chat windows that have to mark messages as read, and the chat bar with the users, and so on. So there's many pieces of UI that have to reflect the exactly same state. So if these are different models, they will get out of sync. And people were complaining about this all the time. They would file bugs with Facebook, like Facebook releases some kind of post on their developer blog about some cool feature they added, and people would write, the top comment would be, fix the goddamn counter. Like, what are you doing?
That's nothing to do with me, I'm sorry. I've just done this awesome thing. I wouldn't mind you looking at this, but no, please fix that. That's the only thing we care about. Oh, yeah,
dear. So they have this problem too, and that's how they kind of came to Flux. And Flux isn't really new. It's a variation of CQRS pattern. It's some kind of enterprise pattern where you it's more related to database. It says that instead of when you have an application that writes to the database, instead of transforming some business logic, instead of doing some transformations and business logic in the app and then write into database, you should write to the database and then read from the database so that your state is always consistent with what's in database. And Flux is the same thing.
That's it, yeah, because I was going to ask that, like, what can, in the past, like, is it a derived, because we always realise that everything's already been invented. Everything cool's invented, it's just, us bringing it up now, that's always, unfortunately, the way it is. And, secret, command query separation. And yes. You can see that, can't you, throughout it, that, oh yeah, this is how they've kind of thought of it. And I mean, with Flux, Flux came out and, and it's an architectural pattern, so as you say, similar to MVC. So, we need implementations of it, and very much like MVC, everyone has made their own MVC implementation. I was wondering, what happened? So is there a definitive Flux vanilla implementation that from Facebook that people can use, or do you have can you go around and what differs in this space?
It's an interesting story. It starts with Facebook releasing Flux package, which at the moment included just the dispatcher. So they had this wall of text in the docs about how they're using Flux, and they release a single module, which is the dispatcher. But they suggest that you implement the stores and action creators and everything else that they described in the docs, like the way you like. And
leaving it up to the people. There we go.
Yeah. And they had, they've released some examples, like a chat example, that show the way they think about it. But if you look at the comments of the Facebook employees on Hacker News and podcasts and pretty much everywhere, you'd see that what really happened is that they extracted this Flux pattern from the chat rewrite, and the way Facebook works is that they have an infrastructure team inside that I hope to be part of. And this infrastructure team acts, it doesn't tell anyone what to do. It can't force any other team to adopt some technology. So infrastructure team acts as an agency. They need to sell their tech to the product teams. So what they did is that they started talking to many different product teams, like, here's how Flux can make your life better. And some teams adopted it, but of course every team had a different opinion on how to use Flux and how not to use it. So even inside Facebook, you can find different teams with opposing opinions on some pretty key ideas on Flux. And of course, when Flux released Dispatcher, people were a bit confused about how to write the stores, because the way the examples worked is that they were just event emitters. But that didn't work well with server rendering, because in server rendering, you don't want to have singleton stores. You want to have different stores for every request. You want to have different data for every request. And the reason Facebook did not think about it much, or did not complicate their examples with this, is because Facebook doesn't use server rendering. So they kind of make it work, but they don't complicate their examples with it. And people started trying to release Flux implementations that make server rendering easy, so that when you realize you want to add it, you don't have to rewrite half your app. And I think early on, the popular one was Fluxible by Yahoo, who cared about server rendering. And the first wave of Flux frameworks, I think it was all about getting rid of the boilerplate. Because there was perception that Flux forces you to write a lot of code. And people were looking at the ways to cut it. And the first really popular Flux implementation, aside from Fluxible, was Reflux. And I don't mean to bash it. It lets you write applications in a nice way, I suppose. But I think it's not really a Flux implementation. And I think that was the problem. When people initially heard of Flux, they did not realize the constraints that are important to Flux. So Reflux, it paid the price. It removed some of the boilerplate of Flux, but it also removed some of its nice properties. For example, if you describe every action as a plain JavaScript object, which some thought was an overkill, but if you do that, you can actually record every action, and you can serialize them, and you can send them with your bug reports. So you can get your application into the same state. And it was something Facebook actually used internally when they had bugs in in the messenger inside Facebook.com. They would have opt-in option for employees to file a bug. And when they file a bug, the log of the actions is sent to the developers, so they can reproduce the same bug by rerunning these actions. And if actions are not first-class concept, if you don't have a concept of actions and they are not plain objects, you can't do that. So this is something Reflux can do.
So that's interesting, because as you say, like, if you just start saying, oh, now an action could be a function, then it all goes out the window. The idea of serializing this, being able to be in a determinate state, just goes out the window.
Yeah, exactly. And I think they didn't. One of the problems I saw is that they did not really explain these properties of Flux. So they explained the architecture, but they did not quite explain what it allows. So the next wave of Flux framework, I think it acknowledged that, and it did not try to cut corners in this way. So the next wave, which I call the second wave of Flux frameworks, was all about they wrapped the dispatcher from Flux.
Oh, so the initial ones weren't using were the initial ones using the dispatcher from Facebook, or were they making their own implementation of that too?
I think a lot of initial Flux libs did not use the dispatcher in effort to make it simpler. But eventually people started, I think Fluxible was an exception. Fluxible used the dispatcher from the beginning, but a lot of Flux frameworks tried to get away from it. But eventually they kind of figured out that they want some kind of compatibility with the Flux ecosystem. They want to try to build some tools on top of it, like recording and replaying, and you need some kind of common code to bind it, right? So they wanted to standardize on using Dispatcher and wrapping it to add some syntax shortcuts or API shortcuts, but without hurting Flux. And I think it was also important from the marketing standpoint of view, like you want to say that we're not reinventing Flux. We're using the Facebook implementation. We're just adding some sugar on top of it.
That's it.
Like the kind of sugar you'd add in your app anyway. So yeah, this was the second wave of Flux frameworks. And I think the Fluxible State and the most popular ones were Alt and Flumux. And Flumux was the one that I really liked, although Alt is really nice too. Personally, I find that Alt has a lot of API, and in my opinion, that's not a very good thing because there are just so many ways to do the same thing in Alt, and if you use it, you kind of get your code. You invest in these APIs. You invest in them, staying around. You invest in your team, learning about them. And I don't mean this is a bad thing, but it's something I personally try to avoid. I'm really afraid of investing into APIs, and that's why I liked Backbone and React, because unlike Angular, they have small APIs.
That's it. Easily to understand. You can learn it in about half hour, and you can
easy to throw away if you realize that it doesn't work. So staying with some API that you can't get away from was a real bummer for me. I don't want to have this problem. And I liked Flumux for this reason because it had a really small API compared to many Flux implementations, and it treated async as first-class concept. It embraced the promises and the ES7 async await syntax. So you could write async action creators with async await experimental syntax, or using promises, which is pretty much the same thing. And it looked really nice. So I liked Flumux. But I think that's the best we had. And later, I was working on my talk for React Europe. And I wanted to showcase some cool stuff like hot reloading and time travel. And I wanted to figure out how to fit it into Flux without forcing the user to write any code, any extra code for these developer features. And it's also similar to how Flux frameworks, they allowed for universal applications, the apps that run on the server and on the client. But there is this problem of transferring all the state from the server to the client. So you need to serialize it to JSON and somehow hydrate into the Flux stores at the client. So many Flux frameworks force you to write methods like hydrate and dehydrate to implement this kind of thing. And it seemed artificial to me, like we already know that the store has a state. Why do you have to write special methods to put it in
that state? That's it.
Yeah, and I think Alt got the closest to getting it right because it didn't force the user to write any code. It just said if the state of your stores is just JavaScript objects that can be serialized, Alt lets you has a toJSON and like load JSON or something like this methods to just load the state for all stores, and I like that. And when I was working on my talk, I tried to use different Flux frameworks, but none of them allowed the kind of hot reloading I wanted to implement. So if you saw that there was a tweet, I tweeted, yeah, like, oh no, am I really writing my own Flux framework? Because I was trying not to do that for...
You try so hard not to.
Yeah, exactly. I was hoping someone would write something I would use, and Flumux was the best choice for me for a lot of time, but then I realized it just can't do what I wanted to do. So I wrote something, and I had this pun in my head, like I was thinking about the Flux as a reduce operation over time. Like if you know, the reduce signature is accumulator value, and it returns the accumulator array reduce function. I mean, And a lot of people describe Flux as this function, like your stores, they accumulate the state in response to the actions. So it's not like you use reduce method, but it kind of it
follows the same ilk, doesn't it?
Yeah. So I was thinking of taking this further. Like, what if your Flux store was actually not a store, but a reducer function? And I was looking for implementations that do that, and I didn't find any. So there was Nuclear.js, which was kind of similar, but it was not exactly as I wanted it to be, and it did not support autoloading the way I wanted to implement it. So I had this plan in my head, like we take the Flux and we take the reducers, so we get Redux, and Redux is actually even a word in English. I didn't know that. So I think that was the main reason I actually created this project, is that it just the pun felt right. So I made it into an actual project instead of a demo, and early on I decided I might not make it in time for the conference.
Yeah, because how long was this before the conference?
I was thinking about it a lot, but I was busy with React D&D, the drag and drop project.
Yep.
So I started working on it the month before the conference. And I was very anxious about it. I was really scared because when I submitted the proposal for the conference, the hot reloading with time travel, to be honest, I had no idea what I'd be presenting. So I was thinking some kind of time travel with the React state going forward and backwards. But the more I thought about it, the less sense it made, because the components contain each other, and if you just time travel one component state, you want to time travel all of its child component state, so it doesn't make any sense. And the more I worked on Flux applications, I was thinking, like, what I really want to do is I want to time travel the Flux stores, and I want to hot reload them, and I want to see the current state change as I change the logic of these stores. So this is what I was after, and I was really afraid I wouldn't make it in time. And I wanted to ask somebody to collaborate, and I reached out to Andrew Clark, the Flummox guy, and he was very supportive, and I think he saved the project because he offered help in implementing extension points like middleware and store enhancers. No need to go into the detail, but that's what made Redux so it's what made its ecosystem possible, because in Redux we have an ecosystem of tools around it, which is not the case for Flux, unfortunately, because Flux frameworks all have different contracts that are incompatible. So in Redux, Andrew really helped solidify the vision, and he helped to come up with an API that made sense and that made time travel possible eventually. And so this was our joint project. And now people sometimes describe it as Flux, and sometimes they describe it as not Flux, because Bill Fisher, the creator of Flux, he thinks Redux is Flux, because it follows the same idea that state plus action returns the new state.
That's it.
Yep. Yeah, and the rest is implementation details. And some other people think it's not Flux because in Flux you have dispatcher, and in Redux it turns out you don't actually need the dispatcher because it's just functions calling other functions. And I need to note, this is a disclaimer that I make every time, that I think Redux was influenced a lot by the Elm architecture. Elm is a language created by Evan Zaplitsky, and Elm architecture is a document he wrote about how to create applications in Elm, and he was influenced by Flux himself. And I think I read it some time before creating Redux, and I didn't get it fully, which you can see by the alpha versions of Redux that were not like Elm architecture at all, and that was a problem. And Andrew Clark actually helped make it more like Elm architecture. But yeah, credit where it's due. I'm pretty sure I was influenced by this. And later on, I alluded a lot to Elm in the documentation, so that was a big influence. And the way Redux kills the dispatcher and just uses functions is similar to how Elm architecture does it.
Yeah, because you have a single root node, don't you, or single root store that a reducer that then goes down, and you can then build these up because they're just functions. You can compose it all together into, and that allows. Exactly. Yeah, and one interesting thing, because of looking at all these things, and it's very cool the way that you're able to work out if something's changed based on, if you're using this immutability, you can just check if the reference is the same, and I know it's the same data, underneath it. I'm just wondering, like, the performance implications. Have you found that in production at all? Have you been able to release something in production that you've been able to see? Does it perform well at scale?
Yeah, I think it performs fairly well. I haven't written large applications with it, but I heard feedback from some people who did, and they say it's fine. When of course, copying large arrays or large objects is a problem, but you need to remember that when we say a single application, a single object describing application state, like, that's not entirely accurate, is it? Because objects reference other objects.
Yeah.
So it's not like you have some giant object you clone all the time. That's not what happens. Only the parts that you need to change are copied. And again, if you have an array of thousands of objects and you need to add a new item to the array, you're not copying these thousands of objects. You just copy the array and it keeps the references to all existing objects, but you have a new object in the array now. So it's important to understand the reference semantics of JavaScript here. But yeah, of course, often copying, like if you dispatch tens of actions per second and you have really large data sets, you're better off using something like Immutable.js, which has better memory characteristics because of structural sharing. And of course, you need to keep in mind, like, what parts of my state tree change, how do I make it more efficient. But I don't think it's really different from Flux in this regard, because if you're really insistent on it, you can mutate state in Redux. We just don't encourage it. But if you have a perf bottleneck that you have no other way of fixing, yeah, you can mutate the state, or you can use multiple stores. Like, these are escape hatches that you can do if you have to.
I like that. The idea of the escape hatches, again, you're bringing that into it.
Yeah, but it's not really something you do often. And if you dispatch hundreds of actions per second, you need to rethink how you use Redux, because user can't click 100 times per second, and the network requests can't come 100 times per second. So there's somewhere you're over dispatching.
Yeah, so in your thinking of the design, maybe you need to review that as instead of blaming the tool.
Yeah, like maybe you need to have some kind of a loop, animation frame loop, where you dispatch actions. You can batch them. There are tools in the ecosystem to batch several actions as a single dispatch. So yeah, you can do all that.
And with this project Redux, have you found that the Flux team in Facebook have kind of, how has it kind of influenced other Flux implementations and how people think about it?
I think a lot of people refer to Redux as the Flux framework to end Flux frameworks, kind of in a jokingly way, but I haven't seen any new major implementations after Redux. So there are some Flux implementations that elaborate on the Redux ideas or try to get away with less boilerplate, as they consider, but I haven't seen them pick up a large following. So I think the ecosystem really helped. Like finally, we have a Flux framework that you can write plugins for, and they work, and people then can compose them, and that's a big deal because it wasn't possible before. People didn't do that. So that's what's keeping a lot of people there. And another reason is that it's really tiny. If you remove the developer warnings and the comments, you can actually fit the whole code of Redux in 99 lines.
That is impressive.
So, yeah, that's one of the reasons people really like that they can fully get it.
Yeah.
Like
that's it. They can look at the source in one sitting and understand it, as opposed to this black box that they can't get slowly.
You don't need to debug its guts, and there is no asynchrony in guts. Like you don't really have to try to understand some complex logic. So I think that's the reason why there haven't been major Flux frameworks after that. So I've seen people converge on Redux. I've seen people using Flux package again, because Flux released what they call Flux utils.
Yeah, I noticed with reduce stores and things like that.
Yeah, these are just from what I understand, these are the tools that different Facebook teams agreed on having, and they are pretty much the same stuff that the most Flux frameworks had at the time, like a container component for binding React components to the Flux store, or a reduce store, which lets you write a store with a reducer, which is similar to Redux. But it doesn't have the benefits of Redux, because if you still have multiple stores, you can't easily compose them. But yeah, I think this is where we ended up. We have Flux, Redux, and we have a lot of people who are who now understand Flux enough to actually not use it at all, and they are jumping to hand-rolled Flux using Rx, for example, because Rx provides a much better asynchronous story. So Flux lets you streamline the mutations by introducing a single synchronous point where you describe mutations as plain objects. But Rx lets you straighten the asynchronous code. So if you have a lot of requests you have to make, some of these needs to be cancelled by each other, and you need to transform their values and aggregate them and so on, you better use Rx, because that's what it's for.
It's like the reactive functional programming paradigm.
Yes, exactly. Yeah. And by the time you use it, you might not need Flux anymore, because both Redux and Flux, they kind of correspond to a Rx scan operator. So it's very similar to scan, and like if you understand the Rex, you can implement Flux in 2 lines, so it's not a big deal.
That's pretty cool. And because all this has been open sourced, and another open source project you do is the React hot loader.
Yeah.
And I just want a kind of a side note, like how did you get into the open source world? Like were you in the open source world when the C# stuff, using NuGet and things like that, or was it really when you got into the JavaScript world that you kind of embraced it and started contributing?
I didn't participate in the NuGet stuff, because I think it got popular after I left C#. And I had I open sourced one library in C#, but that was it, and it wasn't very popular because C# wasn't really an open source kind of thing back then.
Yeah, Microsoft has slowly started to make it more, appealing.
Yeah, it wasn't popular, and I think my first popular project was React Loader. Yeah, I tried to contribute to a few projects, but just by a little. I wasn't comfortable with the build tools and all the build straps and the Travis and all that kind of stuff. It eluded me. So I started slowly, but then I had this idea. I saw Webpack. When I ported the project to Webpack, I read about hot model replacement and the ability to swap out parts of code in real time. And on the other hand, I was curious about Reactor, and I thought that maybe I can make them work together. And I had a very dirty proof of concept where I added a lot of junk code inside React to make it work, and I specifically did things that worked inside my demo. But anyway, I recorded a small demo video saying like, have you seen stuff like this, where I just edit my application, press save, and it updates without destroying the scroll position, the state, everything just works. And I shared this video, I think it was 6 a.m. My wife was like, what the hell are you doing? Like, get back to bed. I'm going to die like in your 40s if you keep doing like that. But anyway, I was very keen on making this happen. And when I got to proof of concept, I can record a screencast of it, and I shared it on Twitter. I registered a Twitter account when I saw pretty much everyone on the Twitter. I had maybe like 20 followers back then. And so Christopher, I'm not sure, Shadow, anyway, the Vijux guy from the React core team, he's a really nice guy. He's very friendly and very embracing the ecosystem and helping everyone see the new cool stuff.
That's very cool.
He's watching out for everything. I can't imagine how he keeps up with everything that's happening. But
he's a robot, is that?
Yeah, but he retweeted me, and it went like crazy. So people kept retweeting it, and I kept getting followers. And I realized, yeah, people want this. People want to make this happen. So I couldn't work in it during my work time. So I took a vacation, and at first I didn't want to write any code. But then, I would swim and lie at the beach, and then I realized, now I need to do this.
That's it. You got it in your head. It's a niggling in your head that you need to do this. And so Hot Loader. So that is built on Webpack. And just for the audience, what is Webpack? Like a kind of a beginner's...
Webpack. It's a tool. It's 2015, so you probably use something to bundle your JavaScript code, and you don't write everything in a single file, do you? Or if you have a large application, it gets really tedious to add every file as a script tag, because you may have, if you have modular code, you might have 100 or 500 of these files. And you need to remember their order because they're dependent on one another.
Dependent, yep.
Yeah, so that's a pain. That's a big pain. And you might use something like require.js. That's what I used at first. But it's not a very good tool. I think it was good at the time, but it's not very modern. So Webpack is... you might have heard of Browserify. So the Webpack and Browserify, they kind of do the same thing. They let you... bundle your code, compile it into a single file from many JavaScript files, and unlike simple concatenation, they actually understand the dependencies, so you don't need to think about the order of the files. They figure it out by how you require files from other files, by your dependency graph. And of course, you can use transpilers with them, which is pretty popular in React world. So React has this JSX optional syntax, which is pretty popular, although some people hate it. But anyway, this is how React kind of taught the developers to use transpilers. And when Babel came out, it was a really easy switch. So now a lot of people are using Babel, which lets you transpile ES6 code to ES5. And Webpack is just a tool that does this for you. It lets you specify the transformations, just like Browserify. It lets you bundle all JavaScript in a single file, lets you apply plugins like Uglify, or adding revisions to the file names. So it's pretty much a kitchen sink approach to how do I get from my source to something I can ship as the part of the production build. So that's it.
That's brilliant, yeah, and so with Webpack, and then it's the hot module replacement that it was able to do. So essentially, that just finds out what's changed and only emit that change to the server, or to the browser, or to
Yeah, it was the creator of Webpack, Thomas Coppers, he's just a machine. I don't know when he sleeps. I think everybody's really nervous, so like if he burns out, who's going to do all this Webpack development? Because he's like the force behind all the project, and he's really interesting because he kind of likes to go into some experimental directions. So I remember somebody requested an issue, like it would be cool if Webpack could compile the changes, like when you change your code in the editor, it would be cool if Webpack could emit just those files as separate JavaScript files, and then you could have some runtime that decides what to do with them. And Tobias was like, yeah, that sounds cool, so I'm going to write a specification for that and then implement this. And he called it hot module replacement. He didn't document it. It's kind of hard. That's the biggest complaint about Webpack, that its docs are essentially a wall of text of everything that's supported. And when beginners come to it, they're like, I can't understand this kind of stuff. But after a while, if you see the projects using Webpack, you kind of get a feel for what people actually use there and what they don't use and how you use it. And it's really powerful. Lets you do anything you want. And people often contrast it with Browserify, where Browserify has this modular approach. You need to use different models for different things. And Webpack is like everything is bundled into a single project, and some people hate that. But anyway, Webpack was the first to came up with this hot model replacement. There are some projects now trying to implement this in Browserify. I'm not sure how complete they are, but it's really cool that we have conversions on some kind of API for that in different bundlers. I'm really hoping that eventually React Native Packager might get support for that. That would be sweet. Sorry, what was your question?
So it's just saying what Webpack is, and as you say, it's this and the hot module replacement, and you use that then. So with the React hot loader, you're able to take advantage of that then to apply it to the React stuff.
Yeah, I remember reading when I was maybe 15 years old. I bought a book on Erlang, which is a language used for networks, like GSM towers use Erlang. And it's a functional language. It has a great concurrency model, and it has a lot of interesting decisions there. And one of those interesting things about Erlang I remember striking me as unusual is that it actually has a mechanism for replacing the code on the fly. So if you have a GSM tower serving millions of customers, you don't want to go offline, right? So what Erlang lets you do is that it lets you replace parts of your app as your app works, and your app doesn't have to stop, because Erlang is a functional language, and as long as you avoid local state, you can just replace the function with another function, right? And so the code is going to call this new version of the function now. So this is something Erlang supports. This is something ClojureScript supports via a tool called Figwheel, developed by Bruce Holman. You should watch his talk, live development ClojureScript with Figwheel. It's really, it's very nice to look at, and he's a really kind guy. He's so warm. I really like watching his talks. And so, anyway, I remember this passage about the replacement of code and on the fly. And when I read about Webpack's hot model replacement system, that's exactly what they were describing. And Tobias even had a way to deal with side effects. So in JavaScript, you have side effects, you have mutable state. So you need some kind of way for the updated module to dispose of its, undo everything that it has done, so that the next version of the code, when it executes, can do it again. And he only used hot model replacement for CSS. So it's interesting that in Webpack, the CSS live editing support, it doesn't work with some browser plugin or some kind of, extra code for your app. It just works on top of the same mechanism. So your CSS becomes JavaScript that inserts that CSS, and that JavaScript code takes advantage of hot model replacement API. And I figured out that, I can try to make this work for React. I can try to make it work for React by replacing the render method on the fly with a new version and forcing the re-render. And React knows what to do. Like, it doesn't care if it's the data that changed or the implementation of the render method that changed. It just updates the DOM.
That is very, very cool. And you got this proof of concept out. And I know then you were saying, because on another podcast, the Software Engineering Daily one, that you were talking about that, it wasn't under test. And you wanted, to be any change that happened in React, then you'd have to, go and fix it and things like that. So you took some time out, and you've been working on the kind of successor of that, which is Hot Transform. I'm just wondering, how's that going and the progress on that?
Yeah, it's kind of in a phase right now where it's work in progress because React 14 really screwed up some plans for us.
Thanks, React.
Yeah, these are good changes for React, but they are very hard for me because I'm kind of working around React instead of working with React. And it's a temporary measure that I have to take because React doesn't provide the hooks I need. And I'm not sure if it can even provide them in the future or if it's infeasible on some level. I don't know. But I hope to work on it when I'm in Facebook. But for now, I have to work around React. And so there are some problems with the way React Loader worked. And I tried to get around these problems by using static analysis. So I have this project called React Transform, which is actually an umbrella project for several projects. They are all, the main idea is that it lets you specify in some configuration file a set of transforms to instrument all your React components. So it gives your React components to the transformers you specify, and they can do something with them. And in case of hot model replacement, it's going to add hot model replacement code to them, which is like a successor to React Loader. And I was also interested in instrumenting them with try-catch instructions so that if your render method throws, your application doesn't stop. It just displays a pop-up like in React Native. You see this red screen of death. So I kind of wanted the same workflow for a normal React, where you see the error, you fix it in your code, and it immediately works again, and you don't have to refresh. It's a replacement for React Loader because I want React Loader to be, I want this kind of thing to be agnostic of Webpack. I wanted just to rely on hot model replacement API, which is now possible to make work with Browserify. So I wanted to get away from it. But as I need static analysis, I had to add a dependency on Babel. And Babel just shipped another major, Babel 6, which again, I was waiting for it because I needed some hooks from Babel 6 because its plugin API is better. But right now, I'm in this weird stage where I don't have time to work on React Transform right now. I'm busy with Egghead videos for Redux. So it's waiting for React 14 support. It's waiting for React. That is to say, you can use it with React 14, but it doesn't hot reload functional components, which are new to React 14. So a full support for React 14 is coming, but not right now. Babel 6 support is coming, but again, I'm busy. Sorry, I'm just a single person. I can't do everything at once. I have to focus on one thing. So Babel 6 support is coming, but not right now. I hope to make it work sometime in this month. But
well, I don't blame. And also with the move, obviously now to London and all this kind of stuff, it must be a busy time. A busy time. Yeah,
I just spent the last evening filing the paperwork, and it's crazy. So yeah, please bear with me. Wait some time for this to happen.
No, absolutely. And technically under the hood, so how does it do this? Does it proxy? Because I've been reading, you kind of wrap these objects, you'll wrap these components, and you proxy the methods around so you can maintain the state.
Yeah, so that's the big problem, and I'm not sure how to solve it more elegantly. But the big problem is that React reconciliation algorithm, it works the way that if you're rendering component A and then you're rendering component B in the same place, React is going to kill the state because obviously the component changed. So it needs to kill the state and initialize the new component. But in case of hot model replacement, if you're not using browser APIs, like there's a project called AMOC that uses browser debugger APIs, Chrome APIs to attach to the browser and hot replace the code without changing the function identities. This is not what we do. We don't want to depend on the browser APIs and browser vendors because they're a pain to work with. If they break something,
they all change. Yeah,
you're going to maintain it. It's hard to run tests for this infrastructure. You have to run browser builds, and it's hard to contribute to this. And if it breaks someday, you need to ask browser maintainers for a few months to fix it, and be glad if they fix it, right? So I'm trying not to depend on it, just like Figwheel doesn't depend on it. But this is the problem because when the code reevaluates, the component is technically different. So it's the same component conceptually, it's the same button, but it's the different function because it was evaluated at a different time. It's a different function identity. And React thinks like, oh, we're entering something different, so I'm just going to kill all the state beneath. And that's a problem because you have existing instances. These instances have their own state, they have their own fields, they have some kind of timeouts attached to them, like they have intervals. All this kind of stuff is just wiped out. And this makes hot reloading useless for many real-world applications. So this was my big constraints. I need to keep the instances. I need to somehow attach the new behavior to the old instances. And this is why I wrap every React class. And in the future, I will wrap functional components too, just to preserve the identity of the function. So every function is actually a proxy now. And when the code is reevaluated, it's that exact proxy again, but pointing to the new code. So that's how it works. It just proxies every method, every class, and it tries to, like railroad switching tracks. This is just like React Loader and React Transform, how they work. But yeah, it's a pain because it means you have to somehow figure out if this class is a React component so you can wrap it. And you need to somehow wrap it, which means operation on the syntax tree. So you have to depend on something like Babel. And I know I talked with Sebastian Magbich about this, and he's like, "Hey, this thing sucks. That's not how I should do it." And yeah, I know.
You're trying your best.
Yeah, I'm trying my best, but I have these constraints, and I don't want to compromise on them. So any better solution should also satisfy these constraints. So I hope to work with React team on that and figuring out if they can help me or if I can help myself. And it's promising. Perhaps we'll have some kind of API to dehydrate all the state from the component tree and then replace the DOM with new instances and somehow hydrate it again. I don't know. Maybe we'll have something official figured out.
That sounds cool. And thank you again, man, for coming and taking the time. I think I've taken up a lot of your time at the moment.
No, it's not a problem.
It's been really, really, really good. And I'm really looking forward to the fact you'll be in London. So when is that? Have you got a date planned, or are you kind of planning it by ear still?
I'm supposed to start the 1st of December. I'm kind of not sure if I also need to work on getting the US visa because I'll have to travel to US as part of bootcamp program, and my application is scheduled on November 10th, so it's like very pressing. But yeah, I definitely hope to be there in December.
Well, that's awesome. Hopefully catch you at some meetups. Will be great to talk. And the final question really is, so, we've spoken a lot about all this stuff now, and for the complete beginner, they're probably very scared, or, the ecosystem's changing, it's very vibrant. I'm just wondering, do you have any resources that you'd point people to? Would you point them to the Facebook, would you say go straight into Redux? What kind of thing would you say to a complete beginner that's getting into this React Flux world?
I'm working on the ACAT videos for Redux. So they're not out yet, but by the time you listen to this podcast, you may have to wait a few days and they'll be up.
I will definitely add them into the show notes. That sounds very cool. Yeah,
so I really try to focus on getting the basics right there. So it's a series for complete Redux beginners that have no experience with React. And I'm not explaining the basics of React there, but I'm explaining the basics of Redux without really depending on React much. So you can definitely watch these videos if you're interested in Redux. And I know Egghead also has a lot of quality videos about the React basics. And I love this website. I think Flux clicked for me after I watched the Egghead video, so I highly recommend you try this out.
Absolutely, that'd be cool.
There are no bullshit. There is no waving around. It's all very practical, and these folks, they really value your time. But beyond that, I think you want to go through the Thinking in React tutorial, which is on the Facebook React documentation website, and I really mean it when I say go through it, because it's a tutorial. You're supposed to follow it and to actually do the things that are described there, because it explains the most important aspect of React, which is that the state is owned by some component and it travels exclusively top down. So this is a big part of React, and Flux is like an extension of that. So you want to understand that. And other than that, I suggest that I think I learned the most from following people on Twitter. So I think if you're serious about keeping up with what's happening in React world, you should follow all the React core team, and I mean Sebastian Magbich, Ben Alpert, Christopher Viju, and a lot of other folks. And I have an article called My React List, so you can just Google it, My React List, where you're going to find references to like 50 people who are either related to React or who are the people followed by the people who follow. Yes, exactly. So I suggest you follow these people, because you will get a much better sense of what's going on. And
of course, follow Dan as well, because you can follow me too. Yeah, absolutely. Well, thank you so much, Dan, for your time. It's been a really great podcast, and yeah, you've given some really valuable information that I know I've taken on board, and I'm hoping the audience will too. So, and I really hope London and all that goes well, and the US visa goes well, and we should see you in a meetup, and maybe come on the show again if you're free at all.
All right, thank you very much for having me.
Okay, then, audience. Well, it's been another episode of 3 Devs and a Maybe. So until next week, goodbye. Bye.
Bye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.